Okay, so as we move on, we're still looking at probability, but we're going to move on now to tree diagrams. Now, tree diagrams should be familiar to you as you saw them at GCSE, but we're going to try and make sure that we're using the correct terminology when we're working with tree diagrams, and we can work a little bit more with complex problems around tree diagrams. So, just as a reminder, a tree diagram is a branching diagram that allows us to demonstrate, that allows us to graphically show the outcomes of two events which happen in succession, where one event happens after the other. Now at GCSE you probably referred to two types of tree diagrams. One of them was without replacement and one of them was with replacement. If it was with replacement, nothing changed. Whatever scenario you were working with, it stayed or it returned to its original state after the first selection. So just like I have here on the screen, 3 yellow and 2 green. If it was with replacement, after I've selected my first counter, I would replace it. So the probability of me picking that second counter matches the probability of the first. This is a rare occurrence at A level. We're more likely to get without replacement, where the situation changes, where the number of crayons, the number of counters within that bag is going to change after every pick. Let's have a look through this example. So 3 yellow, 2 green, and we're going to select 2 counters at random. We want to find the probability that they're the same color and the probability that they're different colors. The first set of branches are about our first pick, and we only have 2 options for that first pick. It's either going to be a yellow counter or a green counter. So you should draw out your branches and label them at the end of the branch. So this is the standard form we'll use around tree diagrams. Next, I'm going to label in the middle of the branch the probability of that specific outcome happening. The probability that I pick a yellow counter, there are 5 counters altogether, 3 of them are yellow, 3 over 5. The probability I pick a green counter, there's 5 of them altogether, 2 of them are green, 2 out of 5. So here are all the outcomes of the first pick. Now the tree diagram is looking to demonstrate what might happen after each of those first picks. So if I had picked a yellow counter to begin with, I have 1 less counter. I now have 4 counters. 2 of them are yellow, 2 of them are green. 2 over 4 and 2 over 4 for these probabilities. This branch down here is not going to match because it's following a different scenario. It's following a different first outcome. If the first one that I picked is a green counter, yes, I have 4 counters left, but now the makeup of those 4 counters is different. I have 3 yellows left out of the 4, and I have only 1 green left out of the 4. So this would be the tree diagram complete. All the possible decisions that might be made, and the probabilities associated with each of those individual decisions. This is a step that you should be making as soon as you've drawn that tree diagram. So we're going to want to find out the probabilities for each of the possible combinations, the sample space. The probability that I get 2 yellows, I'm going to multiply the probabilities on those branches, 3 over 5 times 2 over 4, 6 over 20. Probability of a yellow then a green, 3 over 5 times 2 over 4 again, 6 over 20. Green followed by yellow, 2/5 times 3/4, 6 over 20. Just coincidentally, a lot of these are coming out to be the same. And green followed by a green, 2/5 times 1/4, 2 over 20. Okay, a couple of sense checks, a couple of things to make sure you know that you've completed your tree diagram correctly. Each of the branches, the probabilities should add up to 1. 3/5 plus 2/5, that's 1. 2/4 plus 2/4, that's 1. 3/4 plus 1/4, that's 1. The sample space and all of its associated probabilities, these 4 that we've written here on the right hand side, those should all add up to 1. 6 plus 6, another 6, and a 2. That gets us 20 over 20. Once again, they add up to 1. This is the kind of thing you should be doing as you're working through any tree diagram problems, just to make sure you haven't made any mistakes. That's what we call a sense check, to make sure that what you have so far makes sense. The probability that they're the same color. Out of all of the possible outcomes, so looking at the sample space, there's 2 combinations that we're interested in. The probability of yellow and yellow, plus the probability of green and green. 6 over 20 plus 2 over 20 cancels down to 2/5. That's the probability that they were both going to be the same. The probability that they're both different. Well, the 2 outcomes we're interested in are yellow-green and green-yellow. 6 over 20 twice gets us 3 over 5. Okay, so this is a standard tree diagram question and how you should approach it now that you're working at A-level. We're going to see how we can move this onto some non-typical tree diagram situations. In this case, as we read, the probability of hitting the target is 0.3 for each shot. I'm going to keep on firing until I hit the target. That phrase, until I hit the target, is important. We'll come back to that. Determine the probability that I hit the target on the 5th shot. Okay, I'm going to start to produce a tree diagram here. For the first shot, there's 2 possible things that might have happened. I hit the target or I missed the target. 0.3 for a hit, 0.7 for a miss. If I hit the target, I don't actually take a second shot, because the scenario said that I keep on firing until I hit the target. So I don't need to continue or follow through the tree diagram through the outcome of H, through the outcome of hitting the target. I only need to continue through the missed outcome. So for my second shot, once again 0.3 and 0.7. If I miss, I'll take a third shot. If I miss again, I'll take a 4th shot, and we're interested in the probability that we hit on the 5th shot. So the 5th shot, very similar branches. I didn't need to follow any of the hits through, I just followed through the misses. So yes, this tree diagram does look different to what you might expect, but I'll tell you now, if you did draw the full tree diagram, it would be massive. It will probably take 2 or 3 pages in your book. So lucky for us, we don't need all of that. We've been asked to find the probability of hitting on the 5th shot. The route that we'll take through this tree diagram is miss for the first, miss for the second, miss for the third and the 4th, and finally hit on the 5th. So we'll multiply all of those probabilities together, and we get 0.07203. So a 7% chance that we hit on the 5th shot. Okay, just want to go through one more with you. So I wrote this question to try and show what would happen if we have some missing information in our tree diagram. Let's say a group of university students were questioned about their social media habits. Half of them are found to use Instagram. 2/5 said that they use FaceTime. And of those who don't use FaceTime, 9/14 do use Instagram. We've been asked to find the probability that a random selected student uses FaceTime and does not use Instagram. Okay, so let's just be careful with all of the information that we've had so far. We're going to produce a tree diagram. Which of these events, using Instagram, using FaceTime, is going to come first? There's a phrase in this question that gives me a clue. We were told of those who don't use FaceTime, 9/14 use Instagram. So that indicates to me in the tree diagram, the branch following on from the people who don't use FaceTime is going to be a branch telling me about Instagram. so I can label the first and the second options accordingly. Let's fill in some probabilities. Now, half of these students said that they use Instagram. The outcomes that will give me Instagram are going to be FaceTime Instagram, no FaceTime Instagram. So the probability of those two added together is going to equal a half. That might not be useful just now, but we'll come back to that. 2/5 said that they use FaceTime, so I can label that. And once again, of those who don't use FaceTime, 9/14 use Instagram. So that's really all of the numbers that the question had told me that I've used to fill in. Like I said before, on a branch, those probabilities should be exhaustive. Those probabilities on a set of branches should add up to 1. So I do know that if I have 2/5 here, I have 3/5 for F dash, for not F, for people who do not use Facebook. If I have 9/14 over here, I know that I should have 5/14. 5/14, that's the probability that someone does not use Instagram if we already know that they don't use FaceTime. Okay, where can we go from here? We don't have enough information about the top right set of branches. And if I go back to that first fact that I wrote down, the probability of FaceTime and Instagram plus F-I equals a half. Well, now I know F-I. We can do some smart rearranging. The probability of Fi is 4/35. I know the probability of this combination is 4/35. I should be able to work backwards to figure out the missing probability on this branch. 2/5 times a number would equal 4/35. What is that number? Let's go ahead and divide. 4/35 divided by the 2/5 gives me 4/14. Cancels down nicely to 2/7, and I can add that to the branch. Probabilities on the branch are exhaustive, so I know immediately that this must be 5/7. And perfect, we're good to go. I've now got a complete tree diagram, and I could probably respond to any question that I was asked from here. We were specifically asked to find the probability that a randomly selected student uses FaceTime and does not use Instagram. So that's going to be the probability of Fi dash, and that's 10/35. That cancels down. That will give us 2/7. Okay, so I wanted to make sure that I've shown you the standard tree diagram question and a couple of modifications on it. The information in front of you, you do need to read through a couple of times just to make sure you've picked up all of the information that's in front of you. All of the information is important and can be quite an indicator to what needs to happen. The phrase "of those who" was an indicator that FaceTime had to come before Instagram. It told me of those who don't use FaceTime, 9/4 use Instagram. That let me know FaceTime was the first set of branches, while Instagram was the second set of branches. Okay, so we'll stop there. You can finish up your notes, check out the pre-quiz, and then get yourself stuck into some practice.